the great marker that I use.
All right. So today we are going to start our hypothesis testing. And we are doing it for the population proportion, the p-hat. So things that we already know about p-hat. P-hat is x over n. We know our criteria, there's technically 3, but we really only verified 2 of them, that n times p times 1 minus p is bigger than 10. Sample has to be less than, is it not on there?
Unless I'm a fool.
Are you?
Yeah, I did not include this slide here, so I'm just refreshing, I guess. So these are things that we know already.
I know, I just like variance.
It's on our formula sheet, so the mean and standard deviation. So all of this that we were doing on our last test is still true. All of these things with the p's. So we still have the same criteria, mean and standard deviation. The only difference is now we are going to set up a hypothesis test with this p-hat. So the p is going to be our parameter here. Remember yesterday we talked about hypothesis testing, there would be a null and an alternative hypothesis. The null hypothesis is going to look like what every time?
H equals.
So h sub 0 and it'll have an equal sign. Then the h sub 1 is our alternative and we have 3 options, less than, greater than, or not equal to. When we go through this, we're looking to see if something is statistically significant, which just means the observed result is unlikely if the null hypothesis is true. So essentially what we're doing is finding the probability that something happened if the null hypothesis was true. And if that probability is small enough, that would lead us to believe the null hypothesis is false. When we find it to be statistically significant, we will reject the null hypothesis. Typically, we reject if our probability is less than alpha. So yesterday we mentioned the alpha, we said it's a probability type 1 error. In most problems, I'm going to give you an alpha level. So if I say alpha is 0.1, if you get a probability that is smaller than 0.1, then we reject the null hypothesis. Otherwise, we fail to reject. It will be different on different problems. Typically, the more serious the situation, the smaller your alpha would be. You know, if you're doing a medical trial, you wouldn't be okay with a 10% mortality rate for your new drug. That would not be okay. But if I'm doing a survey on, favorite school lunch, does it really matter if I'm wrong 10% of the time? No, that's not a big deal. So it will depend on the situation what that alpha level will be. But it will be given to you. You're not trying to create it. So I am going to actually skip this classical approach. It's 2 options for the same thing. And I think it's easier just to stick with the second option, the p-value approach, because it is more similar to what we've done in the past. So I'm just going to jump to this slide and then I'll actually work through this scenario. So what we're going to do, instead of doing our first example with classical, I'm just going to do p-value. So if the probability, this is when we're looking for the probability of our particular situation, and we reject if it is smaller than alpha. So we're finding a probability if we do it this way. So for example, a researcher obtains a random sample of 1,000 people and finds that 534 are in favor of banning cell phone use while driving. So p-hat is 534 over 1,000. Does this suggest that more than 50% of people favor the policy? Or is it possible that the true proportion of registered voters who favor the policy is something less than 0.5 and we just happen to get a sample where it was bigger? So, if I were trying to do this, first thing, we can't test it unless we have a null and an alternative hypothesis. The null is always equal. So we're finding just the proportion equals, and we are trying to test more than 50%, so my null would be that the proportion is equal to 0.5. The alternative is that the proportion is greater than 0.5. It's lovely.
I was just like,
Okay, so if I'm going to go through with this, if we're going to do any calculations, we have to verify that our criteria are met. So just a refresh on that. So we have to check that it's normal, so that's the n times p times 1 minus p greater than 10. My n, how many people were we talking about here?
1,000.
The p, we are talking about when we're verifying our probability model. This is the p that we use in our null hypothesis, separate from the p hat. That's our sample. So my p is 0.5. 1 minus 0.5 would be 250, which is bigger than 10, so we're good. Second criteria, the sample has to be less than 5% of the total population, and we can assume that 1,000 is less than 5% of all registered voters. So that criteria is met. Mean and standard deviation. So pull out your formula sheet if you need to. Same ones that we've done in the past. The mean for p hat is just our population mean, which is the null hypothesis, the 0.5.
They throw me off that we're not using the 534.
We will, but not yet. Our standard deviation is the square root of p times 1 minus p over n. And I get 0.0158. So far so good? So we have to adjust our notes a little bit. Some of the things I put on here were for the classical approach, and I'm not teaching that one. So I'm going to skip this picture for this. And mark that out. That's what you do with the classical approach. But we're just going to do the p-value. So we're going to find the z-score. This is something that we've done in the past. Z is our value. Our value, remember that p hat in the beginning was 534 over 1,000. So 0.534. So it's our value minus the mean. So the mean for our sample was 0.5. Divided by the standard deviation, 0.0158. And we get 2.15. So we are finding the probability. Look at your alternative hypothesis. We were finding less than, greater than, or not equal to. Greater than. So we're finding the probability that z is greater than 2.15. Okay, so we go to our normal table. How do we do greater than? 1 minus. Okay, so if I look up 2.15, that probability is 0.9842. most of the time, I will give you an alpha level. If I don't, we're just looking for anything unusual. What's the definition of unusual? Less than 5%. Did this problem give an alpha level, if you look back? No, there was no alpha level given. So, is this unusual? Yes. So that means if the null hypothesis is true, there is a 1.58% chance that I got the p-hat I did from my sample. So what does that make you think about the null hypothesis? So would we reject the null hypothesis? Yes. I'm going to write a sentence, not that you would have to on your homework, but just so when you go back you understand what this means. So we found that if the null hypothesis was true, there is a 1.58% chance of our sample. This is very unlikely. So we reject the null hypothesis.
There is a 1.58% of our sample. What?
That we found a sample where 5.534 agreed.
Of our sample like that. Okay.
Yes. Another thing I might say, like write a conclusion sample. So, or write a conclusion sentence. So most of the time I'll just say, tell me reject or fail to reject. If I ask you to write a conclusion, you could say there is evidence to conclude that P is greater than 0.5. Where have we seen P is greater than 0.5?
Or H1.
Right, the alternative hypothesis.
Is it always gonna? Was it just coincidence that equaled our standard deviation?
Yes.
Okay.
Any questions then? So, in general, if I'm talking about the p-value, if I say find the p-value, I'm just asking you to find the probability that it happens if the null hypothesis is true. So that's what we found. Our p-value is 0.0158. It's a 1.58% chance that it happens if the null hypothesis is true. So our summary of our process. We always have to start with the null and alternative hypothesis. And it'll be one of these three cases like we talked about yesterday. The p sub 0 that we're talking about is from the population. It is not our p-hat. It's the proportion from the population data. Then we will be given an alpha level. You won't have to make it up. You'll be told that in your problem. So on here, I put the classical approach, but we are not doing that. We're just going to do everything with p-value approach. So you can skip those two slides. So by p-value, we'll get our z, find the probability, and if p is less than alpha, we reject. That's the big thing, knowing when you reject, if your probability is smaller than alpha. And finally, I'll ask you to give me a conclusion. So your conclusion, most of the time, I'm just asking fail to reject the null or reject the null. are you ever proving that the null hypothesis is true?
No.
No, we talked about that yesterday. You're not proving it's true. We are assuming it's true and trying to prove that false. If we fail to reject, we don't know that it's true. We just couldn't prove that it's not. So let's look at another one by hand, and then I'll show you how to do them on the calculator as well. So in 1997, 46% of Americans said they did not trust the media when it comes to reporting the news fully, accurately, and fairly. In a 2007 poll of 1,010 adults nationwide, 525 stated they did not trust the media. At the alpha equals 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997? Very first thing you need is the null and alternative hypothesis. We're talking about a proportion. This is my population. What am I using for my population proportion? The original data in 1997, which was 46%. Now in 2007, I got something different, and I'm trying to see, has it increased? So my alternative is going to be that the proportion is greater than 0.46. Our hope is to get a Z. If we're going to get Z, we need to verify that our criteria are met. So N is how many?
1,000 or 1,002.
Times P, we're using the P from the null hypothesis. So, sloppy, sorry. So N times P times 1 minus P must be greater than 10. And that's 248.4, so that's good. Second one is my sample smaller than 5% of the total population. Right, if I'm going to find a Z, I need a few things. We're going to have the mean and standard deviation for our p-hat. What is the mean? 0.46. It's our population proportion. Standard deviation is the square root. 0.46 times 1 minus 0.46 over n. And you get 0.157. One other thing we're going to need before we can find our Z, we need to know what our value is, so we need our p-hat. Remember, p-hat is x over n. So that's the 525 and 1,010. Are there any questions? Now, if I'm going to use my normal table to get my probability, what do we have to do?
Z.
So Z is our value, so the p-hat minus the mean divided by the standard deviation. the probability that Z is greater than. And I'm doing greater than because my alternative was greater than.
Okay.
We know that for greater than, we do 1 minus. If we look on our table, the highest it goes is 3.49. So we're just going to use the 3.49. We know it's got to be something beyond that, right? But we're doing the best we can from our table. So at 3.49, my probability is 0.9998. So our probability, 1 minus that is 0.0002. Remember, reject if your probability is less than alpha. My probability is 0.0002. What was alpha in this problem?
0.05.
Is B less than alpha?
Mm-hmm.
Yes. So what that means is we reject the null hypothesis. So there is evidence to conclude the proportion has increased. And I'm saying increase because my alternative hypothesis that I was doing is that it was greater than. If my alternative was less than, then I would say there's evidence is decreased.
This one sounds weird. If our answer is like our Z and we're doing a 1 minus is negative 0.52, could we just put the positive 0.52?
Because it's symmetric. Yep. Alright. Any questions there? So it's using all the stuff we've done before. The new piece is we write the null and alternative hypothesis before it, and we have to say at the end, do we reject or fail to reject? Let's look at another one, and I want to show you how to do one on the calculator. So when asked, is it more important to protect the right of Americans to own guns or to control gun ownership? 46% of all Americans said protecting the right to own guns is more important. A research center surveyed 1,267 randomly selected Americans with at least a bachelor's degree and found that 559 believe protecting the right to own guns is more important. Does this result suggest the proportion of Americans with at least a bachelor's degree feel differently than the general population? Use alpha equals 0.1. So, even if you're going to do it on the calculator, you have to write down your null and alternative hypothesis. We are talking about a proportion. When you see percents in the problem, you know we're talking about proportion. My null is talking about the whole population. So what is my null hypothesis? The proportion is equal to what?
0.46.
And then I'm testing if they feel differently. So what would that mean?
Does not.
Let's check our criteria off to the side. My N, 1267, P 0.46, 1 minus 0.46, greater than 10. Get 314, so that's good. Is 1,267 less than 5% of the whole population? So criteria is good, that means we can move forward. Alright, if we are doing this on the calculator, you are going to go to Stat, Tests, and it's number 5. We have a 1 proportion, we have 1 p-hat, and we're doing a z-test. Stat test number 5, 1 proportion z-test. And then it asks us some questions. The p sub 0, that's the p of the null hypothesis, which is
0.46.
0.46. X and n. Look back at our problem. What's our x value? 559. What's our n?
0.26.
And then it asks you to pick. Are we doing not equal to p sub 0, less than or greater than? So this is the not equal. So then you go to calculate. And it tells us. Show me that. It says your z is negative 1.34. Probability is 0.1794. Did everybody get that? So what I'm really interested in right here is this probability. We reject if p is less than alpha. Otherwise, we fail to reject. Is p smaller than alpha? So since p is greater than alpha, we fail to reject the null hypothesis. There is not evidence to conclude they feel differently. Saying if the null hypothesis is true, there is a almost 18% chance that I had a sample with those values. So that is not unusual.
Is P0 the same as H0?
It's saying the p in the null hypothesis, so yes. Alright. Any questions there? We can also use confidence intervals to test these. You guys created confidence intervals on our last test, right? We did it strictly from our calculator, basically. But if you have a p-hat and you create a confidence interval, if p-hat is in the interval, would that be suspicious? No. But if your p-hat is outside the interval, that would be unusual. And so that would lead us to think the null is not true. So that is the other option for how to test these. So let's take a look at that one. A 2009 study found that 34% of teenagers text while driving. A more recent survey found 353 out of 1,200 randomly selected teens had texted while driving. Does this suggest the number has changed? Use a 95% confidence interval to answer the question. So you could do this with the probabilities, but I asked for a confidence interval. Spelled incorrectly, but all the same. So my null hypothesis is that my p is equal to
134.
Yeah.
my alternative. What am I testing?
No, you're good.
Not equal. All right, let's go ahead and verify the criteria. So n is 1200 times p 0.34, 1 minus 0.34, greater than 10. And that one works. And is my sample less than 5% of the whole population? Yes. So criteria is good, we can move forward. if I want a confidence interval, we go to stat, tests. Okay. When we are dealing with proportions, do you remember which one we went to? The one proportion, so we're either doing a one proportion z test or interval in this case.
That makes sense why I couldn't find it when I was doing all the tests. I was going the wrong thing.
So our x here is 353. N was 1200. What confidence level do we want?
95.
0.95. So we get 0.26839 to 3.20. So what this means is we are 95% confident the true value is in this interval. What is the p hat in our problem? Oh, sorry, we don't even actually have to have that because we already, our calculator did it. So it does tell you on the calculator if you want to jot it down. But if we look, my null hypothesis is my 0.34 in this interval. No. So I'm 95% confident the value is in here, but 0.34 is not. So that does not contain the 0.34. So we reject the null hypothesis. I'm writing a lot more words than I'm expecting of you guys, but I want you to have something you go to look back to understand what we're talking about. Basically, most of the time I'm just going to say, tell me reject or fail to reject. Sometimes I might say, write a sentence. So if I ask for a sentence, it would be there is evidence to conclude the proportion is not equal to 0.34.
Where did you get the 95%?
It was given in the problem. The 95% confidence interval.
Oh, I see now.
Other questions? Okay. I'm going to stop here. I need you to get out your homework packets and I'm going to make a couple modifications. So on question number 6, it says to do the classical and p-value approach. Just mark off classical, you only need to do the p-value approach. Okay, I did ask for you to try a couple by hand, so that one is by hand where you like calculate your z's. And then number 12, I want you to mark that one off for now. We might, if we have time next week, come back to do that one. That one doesn't meet the criteria, so you actually can't do it this way. There's another option if it fails to meet the criteria. But I don't have a lot of time left, so I can't get into that right now. So you can work on